Good afternoon or evening, everybody. My name is Hakeem Weatherspoon. I'm the CEO of Exotanium. I'm also the co-founder of Exotanium, and I'll show you in a second. But I'm also a professor at Cornell University. I'm actually, as a result, in the East Coast of the United States at Cornell in New York. So here is 10:30 a.m. And so today I'm going to present one of the keynotes. Have your cake and eat it, reliably running stateful application containers in cheap spot markets. All right. And so, as I said, I'm the CEO and co-founder of Exotanium. The other two co-founders are Robert Varonese, who is a professor as well, and Ziming Shen, who this work that I'm going to present is based off of his PhD thesis. Robert and I were his PhD advisor. Between the three of us, we have several awards, patents, and companies. In fact, this is related to one of the cloud awards for Symposium Cloud Computing that Ziming won 10 years ago. The paper was 10 years ago, and he actually won the award this year. I actually won an award for also a Tested Time award for cloud storage, a paper I had published nearly 20 years ago in a paper called Ocean Store, and that talked about how to store a cloud worth of data without losing any of it. And then Robert Varonese is one who we would call the godfather of the cloud, if you will. He actually hired Werner Vogels, the CTO of Amazon, and Werner worked for Robert at Cornell. And then they had a startup company in the early 2000s that they then sold to Amazon. And as part of that acquisition, Werner went to Amazon, became the CTO, and created Amazon Web Services. So we call Robert the Godfather. So in any case, so today I'd actually like to talk about something that we've been developing for quite some time. Just as background, to make sure that we're all on the same page. So we're talking about infrastructure as a service clouds. So this is where you can get virtual machines on demand and seemingly unlimited number of them. So as much compute, storage, and networking as you want. And this is a pay-as-you-go model. And everybody has started using this. In fact, Amazon, Google, Microsoft are making trillions of dollars. That's 12 zeros. The issue is this is covered a bit, but the problem says that businesses are spending billions of dollars in the cloud, and much of them are spending as much as 50% of their revenue in the cloud itself. And so what we're going to want to do and discuss in this talk is how do we actually tame those costs, okay? And the thing that we're going to use is what's called the spot market. The spot market are the same virtual machines, but can be up to 10 times cheaper. You can see here on the graph on the right, the price of different instance types varying over time. And so as a result, you're going to want to use the spot market if you can, because it's going to be much cheaper. However, the issue is that it's very unreliable. Applications can be terminated at any time. And as a result, your application needs to be able to handle failure. So if you have a stateless application, one that you can auto-scale or restart at any time, that's perfect. If you have a stateful application or legacy application, then you would never use this. And just to make sure we're on the same page, the way to imagine a spot market and where it comes from is just like a hotel room that's empty or an airplane seat that's empty. That's lost money for that hotel or airline. And as a result, you have companies like Priceline that sell essentially those unused rooms or seats much cheaper. In the same way, the cloud has to have machines available to respond to anybody that wants to use them. If somebody wants 10,000 machines, it has to respond with 10,000 machines. As a result, those 10,000 machines are sitting there idle, wasting money. And so what they have done, Amazon, Google, Microsoft, all have their own versions of a spot market. is they sell these unused machines much cheaper, with the trade-off that if somebody wants to pay the full price, then they will terminate your application and start running, a person that's able to pay full price. And so that's kind of the underlying reason for this spot market. And so what we're going to want to do is we're going to want to use this spot market because it's cheap, but we're going to want to use it reliably. So how is it that we can mask the unreliability of the spot market? Furthermore, we're going to not want to require any changes whatsoever of the application. And finally, we're going to want to achieve good performance. In summary, we're going to want to have our cake and eat it. We want it all. Okay? And so the key here of what we're going to do is we're going to use a technique known as live migration. It comes with Zen by default, so there's nothing special there. And there is some animation that maybe I don't get. Okay, so unfortunately I don't have an animation here, but there's animation that shows essentially, you can migrate a instance from one machine to another. And if you were the cloud provider, you could do this at any time because you have installed the virtual machine monitor, the Zen hypervisor, and you can essentially migrate all the virtual machine state from one machine to another. So as a user, as the owner of the physical machine, you can migrate a virtual machine anytime you want. As a user of the cloud, you cannot. And this is because you don't have access to this underlying virtual machine monitor, or Zen hypervisor. So the question is, how do we then enable virtual machine migration at the user level if we are not the underlying provider? And so we're going to use the oldest trick in the book in computer science, which is we're going to add another level of indirection. Instead of starting a virtual machine instance, within an instance, we're going to start another virtual machine monitor. So we've created a nested virtual machine that we call Zen Blanket. This actually was discussed in a research paper that I wrote nearly 10 years ago, and you can see the reference here. The Zen Blanket virtualized once, run everywhere. And essentially what we're going to do is we're going to start a virtual machine hypervisor that we call Zen Blanket. And then within that, we're going to start a second layer virtual machine. So the FVM is the first layer virtual machine, and the SVM is the second layer virtual machine. And then what this is going to enable us to do is now all of a sudden we are going to be able to do everything the provider could do, which means that we can migrate all of the state, all of the virtual memory and registers related to this second layer virtual machine to another target location. So we can do everything that the provider could do, even though we do not own the underlying virtual machine. Okay, and everything is going to be migrated. I should say one thing is that we're using for the second layer para-virtualized operating systems, whereas we're not going to be able to use the hardware virtualization for that second layer. So that's one constraint. Okay, let me go next slide here. And this works so well, it even works across different availability zones. So another paper that I wrote almost 5 years ago is a paper called Super Cloud, a library cloud for exploiting cloud diversity. And here, the same trick works. You can migrate, you'd run Zen Blanket in another availability zone, and you could, as the owner of that second layer, so anybody can own these virtual machines, you then would migrate all the state related to that second layer virtual machine to another availability zone. This works perfectly fine. Okay. there are some constraints related to this. You would need to pay to migrate the state across availability zones. Also, if you're accessing storage, you're not migrating that storage. And so you would still, those requests would still go across the different availability zones, and that would cost money. However, you can actually migrate across not just availability zones, but different cloud providers. If you go to supercloud.cs.cornell.edu, you can click on a demo there and see where we start an instance in Amazon, and then we migrate it live to Azure, and then we migrate it live to Google Compute Engine, and then we migrate it live back to Cornell in what we call the Red Cloud. We can migrate to any cloud we want live, okay? But there are some constraints, like I said. So we actually do have a multi-cloud, which is exactly what the supercloud is. The last thing I'll say about this is, even though that capability is there, it turns out that it is expensive, and you have to be very careful about the storage, the networking, the scheduling. The supercloud actually has a solution for all of that. It has a storage layer, a way to use software-defined networking, Open vSwitch, in order to migrate and maintain the same IP addresses, and also it has a orchestration layer. All right, so this has all been researched over the past 10 years so far, and then finally we want to then get into actually using the spot market using this technique. So let's review a couple things about the spot market. Number one is that the price varies over time. And so you can see a chart here with the price as low as nearly 1/10, and it also could be more expensive. So anything over 1 is more expensive. And so normally you would set a bid price, and you would not use the spot market if it was more expensive than an on-demand instance. The other thing is that the spot market varies based off of instance type. And so you can see here two different families, the M3 and C3 family, and then large and extra large within them. And you can see that they all vary based off of their own instance type and family. Okay. And then finally, a spot instance varies based off of availability zone. So you can see here the US East 1B, C, D, and E zones, availability zones, and the same exact instance type, the M3 large in this particular case, varies differently based off availability zone. So as a result, you have the price vary based off of time, instance type, and availability zone. Okay, and so we're going to want to, really what we want to do is at all times run on the lowest type and availability zone. And so that's what we're going to want to do. And so what we then have created is what we call a smart spot instance. So we're going to run the application in these second layer VMs, okay, and then we're going to migrate that second layer VM to a different target machine every hour based off the price. So we're going to monitor the price of instances and availability zones, and we're going to each hour potentially migrate. The other thing to note is that we will also only run the instance in one location. So after we migrate from the source to the target, then we will terminate or destroy the source. Okay. There's a statement there about performance. So I'll talk about that a little bit because we're actually going to want to make sure that despite the overhead, we're going to want to essentially minimize the overhead as well. And so I'm going to show a experiment here of the price over time and what we're able to achieve. And this was talked about in another paper called the Smart Spot Instances for the Supercloud. And the references of all these papers are here, and you can go and read up on any of these, and also follow up with me if you have any interest or questions or whatnot. So in this case, we're going to run 10 applications that are all running a TPC web workload. They're going to run over 24 hours. We're going to run them in one availability zone, and we're going to have compare it to 3 instance types: the M3 large, extra large, and double extra large. Okay, and so this, if you focus on the top here, then you can see the price over time for the large in green, the extra large in blue, and then the double extra large in like a maroon. And then you can see that when the price changes, there's a vertical blue line, and those are the times that we are going to migrate. And so as a result, the supercloud, and this is cumulative price over time. Time is on the x-axis and a cumulative price is on the y-axis. You're going to see that the supercloud is at all times the cheapest. In fact, if you had an Oracle, it would be able to achieve within a constant factor that Oracle lowest price. And the difference between the supercloud price and the extra large price is 3.5x in this example. In the paper, it shows that we're able to achieve on average up to 7 times cheaper price. What about performance? So this shows the web requests that we're responding to per second is a red line. The blue vertical line shows when we were doing the migration. And what you can see here is that the same performance was maintained over time. We were able to respond to all web requests at the same rate despite migrating to different virtual machines at a time. And just to go a little bit more into that, it's a normal live migration. So there is a pre-copy phase, and there's a couple rounds of that, and then there's a stop and copy. So all of that is still true in this case. The key here is that we're just minimizing that stop and copy time, and it's running during that entire pre-copy time. And so that's why you don't see any degradation in performance. And then lastly, that stop and copy is a fraction of a second, such that we don't actually break the network connection at all. And we are migrating the IP addresses. I'm not going to go into that lower level techniques. You can actually read the Zen blanket paper to see some of the details there. Okay. And next, does this actually work for real? Nice research, great job, professor at Cornell after all. But what about real applications and workload? Okay, so this is where Exotanium comes in. So we've taken that technology that I've demonstrated here, and we've demonstrated that we can actually achieve a very high reliability while achieving a very low cost. And high reliability means that if you were to run in the spot market today, then you would expect, they actually give you the interruption rate of the previous month. So if it says 5 to 10%, you'd expect 50 to 100 terminations out of 1,000 starts. Or if it said 10 to 20%, that'd be 100 to 200. We actually are able to mask all of those, and I'll show you that in a second. So we're able to do that via seamless migration. It's a plug and play, so it's a virtual machine and doesn't require any change of your application. And then it's going to work on any cloud: Amazon, Azure, Google, IBM, VMware. Okay, there is a link in the chat to supercloud.cs.cornell.edu. As a case study, we've done this for fairly reputable companies, Fortune 1000, that have fairly challenging workloads. So as you see here, stateful, long-running, tens of CPU cores, hundreds of gigabytes of memory. And what we've achieved is a low cost, reducing over 60%, nearly 2/3, and a performance overhead of less than 6%. So that means that if it took 10 hours for this particular run or set of runs, then it would take 10 hours and 15 minutes, something that's in the noise for many of these applications. So this is a batch application. You can start it sometime later. What about interactive? If I had a server, unfortunately, this is a demo that I'm not able to play, but I can describe it a little bit. This is a normal 3-tier application. So it has a database, a Redis database, which you can see here in red, and a web server front end and load balancer and whatnot. So what we're going to do is we're going to migrate the stateful Redis database. And this shows the green line is the web request per second. The red lines is the errors. And you can see the second layer virtual machine running here in the top right. And if I was able to show the demo, what you would see is that I would migrate the virtual machine, second layer virtual machine, live from the spot instance to the regular instance. And it would be almost magic. It would not stop at all. The green line would continue to run and respond, and there would be no errors. And then I would migrate it back. So that's the demo that you would see here. And the entire time, it would run and respond. And we are maintaining the same network connections. Hopefully you're able to do. Someone said, "Can you share this screen?" Unfortunately, it should be shared. Let me know if you're not able to see the screen share. The demo is not there, unfortunately. So that's the issue. Is I described it but wasn't able to actually show it. And so let me go ahead and actually show another slide or two and then wrap up. So we have been running this for several months now. And what we have achieved is that over several months, the last 4 months, this says 2 months, but we actually have added a couple months since then, that we've actually have avoided hundreds of potential terminations and not been terminated once. Okay, this is unprecedented. There's no way you could run a stateful application in the spot market and expect to run for certain days and not weeks, but definitely not months, and not expect to be terminated. And so we actually have done that for long-running jobs. This shows for the M5 extra large. We have done this for many different types of instances. Okay, and finally, let me conclude, and I'll take some questions. We have demonstrated that you can tame the spot market using live migration. Seamless live migration. This works for application containers and virtual machines. It's based off of research, open research over the last 10 years. We have commercialized this and enabled this to work in production environments. And the name of the product is XSpot. And so you can contact us here if you'd like a demo, or contact me. Also, if you're interested, we are love Zen developers, and we are hiring. We're growing quite a bit. Okay, so with that, you can then see the paper trail of the research papers that we have written and published. And then with that, I'll go ahead and conclude and say thank you and see if there are any questions. I think we have 5 minutes for questions or so. So I can read off some of the questions in the chat. I don't know if anybody's gonna unmute or not, but someone asked that maybe they missed it, but I think it still doesn't actually deal with termination problem. I mean, you still suffer data loss in that case. So true, if you get terminated, you would potentially lose the data. So let me say a couple things. Number one is we're playing essentially a game of whack-a-mole. So we are avoiding termination. We are migrating before you get terminated at all. And actually, we're not actually waiting for that 2-minute warning. There's other stuff that we do in order to predict when to migrate, and we'll migrate ahead of time. This is why we're able to migrate very large instances. We can migrate up to a terabyte instance that may take 20 minutes. And we've been able to achieve the same result, which is many months without termination. The other thing that we actually have is the ability to write checkpoints. In some sense, that is what a migration is anyways, is just writing checkpoints. And so you could write, potentially maintain continuous checkpoints. There's a cost to that. So there's always a cost trade-off of doing that. But if you did, then you would potentially be able to resume after you were terminated. You would not maintain the same network connections for the most part if that were to happen. There's another question: how do you maintain state from the first instance to the second? So a couple things. Number one is that we have a first layer instance, and within that we start a hypervisor. That hypervisor essentially is an abstraction of the machine. So we actually at that point own all registers and all state. And that's why we, even though we're the user of the cloud, are able to do everything a cloud provider is able to do. And we can move all registers, all memory to anywhere we want because, with the whole split driver and everything goes through domain DOM0, and we control the world. All your bits belong to us. And so that's essentially, in some sense, there's nothing special there. What's special is we're able to do it in a performant way on a second layer. Okay. And this says, how do you know when to migrate? There's a number of inputs that you would take. So certainly that warning that Amazon gives you, for example, 2-minute warning. There's different signals on the issue is that the interruption rate is stale. But there's other signals that we take in, and essentially that's kind of the secret sauce is figuring out when to migrate. And so we've mastered that in some sense. Actually, not in some sense, we mastered that overall. So that's a good question there. I think that we have 1 minute left. Somebody said they're asking for the secret sauce. Well, we would love for you to come join us. I should say that this is a lot of this is open. I'll put my professor hat on. I'm a professor in computer science, in computer systems and networking. I've been in the field for over 20 years. My dissertation is based off of distributed storage, and I have results in storage and operating systems in networking. And so we believe very strongly in the open source community. So we have contributed to that. At the same time, open is actually a great avenue, open source for commercial businesses. There's always, I don't know if it's Salman has said it, but free is not open, and free is not necessarily free in terms of making a business. So that's what we're doing right now is we're figuring out how to make a profitable business out of it, which we're being quite successful at right now. And so, the exact details are proprietary. So in any case, there's I think that we're just about out of time. If you have any other questions, you can contact me at ceo@exotanium.io. If you are interested in a demo, you can contact me as well. If you're interested in potentially working with us, contact me directly or send an email to hiring. So with that, I just want to say thank you. This is a great opportunity to sponsor the Zen Summit and to be part of the conversation here. Thank you.